Hello everyone. In this section, we are going to study the two or three-dimensional motions. To describe the positions of particles in three dimensions, we use the position vectors. Position vector is expressed r equal xi by j plus gk's. I is a unit vector is directed on the x-axis. J is a unit vector directed on the y-axis. K is a unit vector in the z-axis. And also we can define the velocity vector from the position vectors. So if the positions of the particle is changing from the rt to the rt plus delta t's, you can find the delta r. That's the difference. Velocity is defined using these equations, delta r over delta t, and take a limit. Delta t is approaching to the 0. Also, we could define the acceleration vectors using the change of the velocities. So delta v over delta t. In the case of the delta t is approaching to the 0. So we consider the constant speed in 1D. One-dimensional motions. So this means velocity v sub old and v sub new. So in this case, speed doesn't change. So this means magnitude of v sub old is equal to the magnitude of v sub new. So in this case, delta v actually is exactly equal to the 0. So acceleration in this case is 0. So if the speed does not change, then acceleration is always 0. Do you think this is true? Actually, it is not. If we consider the particle is moving on a curved path, then in this case, even the speed doesn't change. There is some accelerations. So in this case, the velocity, this velocity is v sub old, v sub new. So if you draw this is the v sub old and v sub new. So magnitude doesn't change. But in this case, to create the v sub new from the v sub old, you have to add the dv. So dv is not 0 in this case. dv is not 0. So accelerations is expressed dv over dt. dv is not 0, acceleration is not 0 as well. So when the direction of velocity changes, then there is non-zero accelerations. Then we'd like to consider the two-dimensional motion. First one is a motion of a projectile, and the second one is a circular motion. First of all, we'd like to consider the motion of a projectile. Projectile is moving under the gravities. The object is accelerated by the gravity only in y direction. Okay, this situation we are going to consider. Then acceleration is expressed. Its acceleration in the x direction is 0. And the acceleration in the y direction is a minus g. Then from these two equations, we are going to find out the velocity and positions in the xy directions. So acceleration in the x direction is 0, so velocity doesn't change. Velocity keep constant values. From this equation, we can integrate to find the positions. X equal x sub 0 plus v sub x0 t. For the acceleration in the y directions is a minus g's. From this equation, velocity in the y direction is a v sub y equal to v sub y0 minus gt. If you think that this is correct or not, you can check by finding the derivatives of the v sub y over dt. It actually is going to become the a sub y equal to minus g's. Then one more integrals to find that y. Y is expressed y sub 0 plus v sub y0 t minus 1 over 2 gt squares. Then we'd like to find out the trajectory of a projectile. We have already discovered the equation for the x and the y. And we'd like to find out the trajectory of the particles. Then both of the x and the y is expressed using the parameter of the t. Then we can remove this t. And the y is expressed as a function of x. So let's do such a calculations. So from the equation of the t, x is expressed x minus x sub 0 over v sub x 0. This t is going to be substitute this equation to find out the y. Okay, so this is t. This is t squared. Then you can little bit change the equations, and then you can easily find from these forms of the equations trajectory is parabola. Then we'd like to write down some trajectory of a projectile. We choose the x sub 0 and the y sub 0 is 0. And the v sub x 0 equal to v sub 0 cosine theta. V sub y0 is a v sub 0 sine theta. So this means x-axis and y-axis, and the initial position of the projectile is located here, and the particle is moving with the speed of the v sub 0, and the angle between the velocities, initial velocity with the x-axis is a theta. Then you can express the velocity, initial velocity using the v sub 0 is the magnitude of the speed of the velocities, and the theta is angle. Using this expression, trajectory is expressed minus g over 2 v sub 0 squares cosine square theta x minus v sub 0 squares sine 2 theta over 2g squares plus v sub 0 squares sine square theta over 2g. Then you can draw the graph. This is x-axis and the y-axis. Particle start with the angle is the theta, and following the parabola. Highest point, highest height is given by these equations, because the first term is always negative or 0. V sub 0 squares sine square theta over 2g. And the highest point reach when the x is this quantity. V sub 0 squares sine 2 theta over 2g. So parabola is a symmetric figures. So this point is twice of this quantity. So this v sub 0 squares sine 2 theta over z. So actually this is the length for the projectile to travel in horizontally before hitting the ground. we'd like to find out the angles. For this length of the L becomes the longest. So L is expressed as V sub 0 square sine 2 theta over G. This capital L is a function of theta. So sine theta, maximum value of the sine theta is 1. So this is always smaller or equal to the V sub 0 squares over G. This is the maximum length for a projectile to move horizontally before hitting the ground. So at the equal means sine theta equal 1. So from this case 45 degrees. So if you draw the graph, x coordinate, y coordinate. So this is a case of the 45 degrees. If you choose a less angle, for example 30 degrees, yes, and also if you choose a 60 degree, it's moving upward, but it's going down, and the same length for the 30 degrees. And you can make some experiment using these kind of device to check actually our theory is correct or not. This is the end of this session.